This model consists of PV and EV battery and then grid. PV going to be connected to the common DC. This is the common DC bus. The PV going to be connected to the common DC bus via this boost converter. EV battery is going to be connected to the common DC bus via this converter, and the grid going to be connected to the common DC bus via this LCL filter and converter. And here the PV boost converter going to be controlled by means of Fuzzy MPPT. That means here you are measuring the voltage and current of the PV. That voltage and current going to be converted into change in power. That means here we want to delay that voltage by one sample, current by one sample, and voltage by one sample. And then you have to calculate P of 1, you have to calculate V of, that means V of n and V of n minus 1, and then P of n, P of n minus 1. From that you have to calculate P of n minus P of n minus 1, and then here you have to calculate P of n minus V of n minus 1. Then you have to divide that P of n minus P of n minus 1 divided by V of n minus V of n minus 1. This is nothing but the slope error. And then for slope error, we are going to calculate a change in slope error. The change in slope error going to be input for that fuzzy. The output of fuzzy will be duty cycle. Here you can, this is a MPPT BO fuzzy already created here. Here you can go that this is a MPPT BO fuzzy. Just you go to type fuzzy and then open that fish file. So this is a fish file. Here you can see that the membership function for error, rate of change of error, and then output duty cycle you will see. And then they are related with the rules. Once you click this rules, right, when you change this value, you can see here the duty cycle will be changed according with the error and the rate of change of error. According with that error and the rate of change of error, the fuzzy duty cycle can be changed in order to extract the maximum power from the PV plant. This duty cycle going to be processed by a PWM generator. So this PWM generator will be generate the PWM pulse. This PWM pulse will be used for control this boost converter in order to extract the maximum power from the PV. Next thing is control of bidirectional converter. This control of bidirectional converter will be done via this voltage control method of bidirectional DC-DC converter. Here you can see that we are measuring the DC bus voltage, and it going to be compared with the 400 because we are going to maintain the DC bus voltage is 400, and it going to be processed via PID controller or PA controller. The PA controller will be generated the duty cycle. The duty cycle is going to be processed via PWM generator. So this PWM generator is going to be generate the pulse for this bidirectional converter in order to control the charging of battery and the discharging of battery. Because here we are going to use the EV battery for charging only. We are going to control that bidirectional converter for charging mode only. Next process, inverter control. That means here we have inverter. Here you have to control the inverter current based upon the power of battery. That means, for example, you are going to fix the charging of battery around 2000 watts. Already here you can see that the PV power is around this 2000. Here we are using. We are charging the battery, EV battery with the 2000 watts. Whatever power generated, when maximum power generated, that will be used to charge the battery, because they will generate 2000 watts directly used to charge the battery 2000 watts, because we are going to charge the battery up to constant power rating. Here you are having converter charging power for the battery, and then it's going to subtract it with the PV. That means, for example, when the power of PV is 2000 and reference power for battery charging is 2000, the remaining will be 0. That means we are not taking any power from the grid. For example, when PV power goes to 1000, then the actual power required is 2000 for battery charging. Remaining power will be minus 1000. Here we are generating the reference current for that the remaining power. For minus 1000, you have to divide with the peak value, that mean divide with the peak voltage. Then here you will get the peak current for that inverter current. Here you will get a reference current in the peak amplitude, and then here you are using voltage will be converted into sine pass by means of PLX. Here we are using phase lock loop. Phase lock loop used for generating the omega t. It is nothing but a phase angle changes with respect to time. VA nothing but the voltage of the grid. Based upon voltage of the grid, right, you will set it in sine and cosine. Then the sine and cosine will be multiplied with the peak amplitude. Next we are applying that, we are converting that AB form into DC form. So by using power transformation. And also here you will see that, right, here you are measuring the inverter current. The inverter current will be converted into AB to DQ form. This will be act as a reference at D and Q, and then here you have actual D and Q for that inverter current. Again, it will be compared here, and then it will be processed by a PA controller. This will be generate the control signal in the form of D and Q. So the D and Q control signal going to be converted to AB form by using inverse path transformation. Finally, we'll get the control signal. So this control signal going to be processed via PWM generator. This is a sinusoidal PWM generator. This sinusoidal PWM generator will be generate the PWM pulse for that inverter. That means so based upon the reference current, the inverter going to be controlled in order to get the power from the grid. When PV will be generate maximum power, that means 2000 watts, grid never supply any power to the battery for charging. When PV power reduce, then the grid will be comes to supply the power for charge the battery, not to maintain the charging power of the PV. Charging power of the EV battery is around 2000 watts. Here you will see that here you can see the measurement block, PV measurement, DC bus measurement, that means DC bus voltage measurement, battery measurement, SOC of the battery, that means EV battery, and then here you will see that grid voltage current and the power of the grid. Here you will see that power of PV battery and the grid. Once you simulate this one, you will see the cells of PV battery, SOC of the battery, grid side voltage current and power. Here you will see that so it is a power of PV. That means here we are changing the irradiation. Here we are changing the irradiation from 1000 to 500 and then 10. Again you have to change to 500 1000 and then you have to check the charging of battery and also power sharing of grid during the charging. Here you will see that the power of PV is 2000 and then here charging of battery around near 2000, around is 1900, and then you can see that when PV power reduced to around 1000 because of reduction in the radiation, during that time what happened, the grid will be supplying the power. Grid will be supplying power at the supplying power to the battery for charging. You can see here during transition the charging power is reduced. After some time it comes to that 1900 watts. So here you can see that when the PV power goes to zero, the grid will supply full power for charging of EV battery. EV battery charging at the rate of 1900 watts. This is a variation of power of PV, EV battery power and grid power. And also you can see that the batteries keep on charging mode is keep on increasing with the constant rate because we are controlling the charging power at around 2000 watts. That means at around 1900 to 2000 watts. Then that SOC of the battery is keep on having this same that mean equal, that mean similar slope for a change in irradiation condition. Now you can see that when PV power increase from 0 to 1000, there is a reduction in the power from the grid because you have to maintain that EV power charging around 1900 to 2000. So that's why the PV power is reducing here when changing the power variation in the PV. Here EVs keep on charging and with respect to change in irradiation condition, this is working of this model. Thank you.